Hello, welcome back. We're going to continue talking about logs and how to solve them. And sometimes, which is basically finding the value for the variable, and sometimes the variable can be located in the input position, okay, or it can be located in the base position. So the good news is that we can use exponentiation, just like we did when we were looking for the value of the log, where the variable was on the right side of the equal sign. And so we were looking for that exponent position, okay? So we're going to do that. And then we're going to learn a new technique when you have two logs that are set equal to each other and you have the same base, some techniques for those situations. All right, we learned this before our last test. If we wanted to solve log base 4 of 1,024, we would set it equal to y, and then we would exponentiate. Now, I might be writing this in a little different way. This will help you move forward. So what we're going to do is we're going to take the input, 1,024, is equal to my base 4 raised to the y power. Okay? And now we're in exponential form. So now I'm going to find a common base, and 1,024 is 4 to the 5th power. And that's going to equal 4 to the power of y. And so now that my bases are the same, now my exponents can be set equal to each other. And this one is self-solving because it's very simple, right? This works when you have an equal sign, a greater than equal to, a less than equal to, even if you just have a less than or a greater than, right? So why don't you go ahead and try your video question and then come on back. All right, hopefully that went well for you. If not, write your questions down and we'll talk about it in the morning. What if the variable is located in the input position? So notice its location. It's not out here to the right anymore. It's in what we call the input position. Okay. The good news is that we get to solve using the same technique, exponentiation. Use exponentiation. So now what we're going to do is we're going to write that our input, x, is going to equal our base raised to our power. Now this is really just a calculator issue now that you've got it set up in the right form. And I want to encourage you, take the index, apply the index first, and then apply the power. And when you do that, I'm going to do it by hand, but you can just plug it into your calculator. This is 4 to the 1/2 raised to the 5th power. 4 to the 1/2 is 2. And then that's 2 to the 5th. And that gives us 32. Okay, try the video question and come on back. All right, so what happens if our variable is in the input position and we have a greater than sign? Well, luckily, we're going to do the exact same thing. We're going to apply exponentiation, and then make sure that we prevent our input from going negative. This has to stay positive. So that means all my values of x have to be greater than 0. Okay, so let's exponentiate. My input, x, has to be greater than my base raised to the 4th power. Okay. You can use your calculator. If you know that 3 to the 4th is 81, you can do that. Right? So I applied the power. Now, could any of my solutions produce a negative input? No. So in interval notation, this would be 81, to all the way out to positive infinity. All the way out to positive infinity. Okay? Why don't you try the video question? All right. So if we have the input in the or the variable in the input position, and now we have a less than symbol, all right? So we definitely have to be careful about a lower limit and restricting that domain, right? Okay. But we get to apply the same process. Exponentiate. My input, x, has to be less than or equal to my base 2 raised to the third power. You can use your calculator to apply the power. So x has to be less than or equal to 8. Okay, well now let's think about that. If I start plugging in negative numbers, what will happen to my input? Well, they would become negative, and we can't have that. So what's the smallest number that can equal or get close to? Because it can't equal 0 either. Well, it's 0. So we're going to write this as 0 to 8 with a bracket, just like that. Okay? All I did was restrict the domain. I just said x has to be greater than 0. And basically, I added it right on here. X is greater than 0. It's just reading it backwards, okay? All right, you try your video question and then mark down any questions that you might have. All right, this is a little bit different one. What happens if the variable is located in the base position? Well, guess what? We get to use exponentiation. The only thing that we have to remember right here, I'm going to use my highlighter right here, is this base has to be bigger than 0, okay? It has to be bigger than 0. The base has to be bigger than 0. It can't have a negative base. Can't have a negative input, can't have a negative base. So we're going to exponentiate again, and we get 1024, we've seen this problem before, is equal to x to the 5/2 power. Now this looks complicated at first, but think about it. How do I undo something to the 5/2 power? Well, I apply the reciprocal of that power, right? So I'm going to apply 2/5 to both sides. So I have 1024 to the 2/5. Whoops. Is going to equal x to the 5/2 times 2/5. And these are going to cancel out, and that way I'm going to get x all by itself, right? That's gone. So now apply the index first, and then apply the power, and then you're going to get 1024, the 5th root of that is 4. And then I'm going to square it. And so I get 16. Is 16 a negative number? Then I don't have to worry about it going negative. All right? If that was a less than symbol, we certainly would have to. Okay? Sometimes with greater than symbols if some funky business happens in there. All right? Okay, so try your video question. All right, now we're going to transition to that part where I said now we're going to have logs on both sides of the equal sign. Okay? And the cool thing about that is if the bases are the same, and the two logs are equal, then the inputs have to be the same. So if you have a single log on both sides and the bases are the same, then what we have to do is just set our inputs equal to each other. Remember that an input has to stay positive. It can't go negative. So then we would have x is equal to 2. And when x is equal to 2, those two logs are exactly the same. Okay? So why don't you try the video question? Come on back. This works with inequalities as well. If one log, you have the same base. So if one log is greater than or less than another log with the same base, then the inputs are also greater than or less than each other. So notice that I have the same base. Let me highlight that. I have the same base. I I have an inequality symbol, so that means my inputs have to be unequal in the same way, right? So now I'm going to solve this. I have the problem log base 4 of the input x plus 7 is greater than log base 4 of the input 14. So my bases are the same. So that means my inputs have to be greater than in the same way. So that means x has to be greater than or equal to 7. And in interval notation, that's how we're going to write it. And that's a bracket, and that's a parenthesis. Okay, so just check your lower limit. The lower limit are any of the inputs. So x plus 7 has to be bigger than 0. So x has to be bigger than negative 7. Is my solution, are my solutions bigger than negative 7? Yep, so I'm good to go. I don't have to restrict my domain. All right, we can do this with an inequality symbol that's less than. This one you really have to be careful of, okay? This one you really have to be careful of. See how I highlighted that? So you're going to want to check the lower limits of both of these, all right, by setting them greater than 0. So 12x plus 5 has to be greater than 0, so x has to be greater than negative 5/12. So none of our solutions can be lower or smaller than negative 5/12. This one is going to produce 10x plus 9 has to be greater than 0. So x has to be greater than negative 9/10. All right. And negative 5/12 is the bigger of the two. That's the one we'll focus in on. All right. But right now, my logs have the same base. So I can solve this as just a simple inequality. And so I get 2x is less than or is less than 4. X is less than 2. All right. But we know, particularly with a less than symbol, we have to be careful that we don't produce negative inputs. So once we reach negative 5/12 and start putting in values less than that, this is going to go negative. So we have to make sure that x stays greater than that. So x has to be greater than negative 5/12. And in interval notation, it's going to be parenthesis negative 5/12, 2, and then another parenthesis. Okay? So we check the lower limit on both sides, pick the greater value. Okay? That's how we got our leftmost point. Right. All right. Sometimes we can get a situation where when we set our inputs equal to each other, we can actually get a quadratic. So we're going to solve it. Most of the time, the way they present these to you, you can use factoring, or you could use a quadratic formula. My bases are alike, so I know that x squared minus 4 has to equal negative x plus 2. So I'm going to move everything to the left. X squared plus x minus 6 equals 0. And now I'm going to factor it. If you want to use the quadratic formula, feel free. This is going to factor into x squared minus 2x plus 3x minus 6, and then I'm going to group, and I'm going to get x times x minus 2 plus 3 times x minus 2. So I'm going to get x plus 3 and x minus 2, which means my solutions are going to be negative 3 and 2. So I have to make sure that both of them work, okay? And so all we're doing is just checking these two solutions. So in negative 3, if I plug that in, I get 9, and 9 minus 5 is 4, okay? So I have log base 3 of 4. If I plug negative 3 in over here, the opposite, sorry, I just said that backwards. I was thinking ahead. This is log base 3 of 5. All right, and now I'm going to plug it in up here, and I'm going to get the opposite of negative 3. Well, that's 3. 3 plus 2 is 5. So I have log base 3 of 5. And it worked. And I'm going to do that with the 2 as well. And watch what happens. Remember that my input has to be a positive. So it can't be negative and it can't be 0. Okay? So if I plug a 2 in here, I get a 0. So this answer does not work. So my only solution is negative 3. Okay? Very good. This is what we're going to be working on tomorrow in class. If you feel like you can't get all those problems done, I encourage you to do a few just on your own here while it's fresh, and then you can check your answers with me tomorrow. Okay? I'll see you tomorrow.